Welcome to the tutorial. Today I'm gonna guide you through the process of installing Minikube and creating a cluster with GPUs exposed. For this, of course, you need a computer, a PC or laptop with a GPU inside, which is an NVIDIA GPU and is capable of running CUDA. So that being said, let's jump to the documentation page of Minikube and let's see which are the steps needed to install the cluster and also to enable the GPU access. So here you can see the Minikube page. Minikube is a way to quickly set up a local Kubernetes cluster on macOS, on Linux, on Windows, and today we're going to install it. So if we go to the getting started page, we're going to see that we have a couple of options here, and I'm going to use the binary download so that I install the Minikube. If we check the prerequisites, we need 2 CPUs or more, 2 GB of free memory, 20 GB of free disk space, and of course the most important, a container or virtual machine manager, which are Docker, QEMU, HyperKit, Hyper-V, and a couple more. We're going to concentrate on Docker, and before we start installing the Minikube binary and setting up the cluster, we need to install Docker. So I have already opened the Docker page here. Docker is just a container runtime. It allows us to run containers on our machine, and it comes with a Docker desktop software, or you can install only the engine, which is the thing that we need because we are gonna use Minikube as our orchestrator. So I'm just gonna go to learn more about Docker and then navigate to Docker engine to install. And here I'm gonna see the systems that are covered by Docker engine. I have Ubuntu, so let's click on Ubuntu and let's keep on installing. I'm gonna pick an installation method. I'm just gonna use the apt repository. Let me open the terminal, and I'm just going to copy paste the commands straight out of the blocks here. Just copy this one, paste it. It's going to add the apt repository. Once it's done, it's going to update, as you can see, our repositories, and we're going to have access to the Docker binaries. So now that it's installed, I'm just going to copy the installation command, which is this one here. Copy and paste it. Oops, I re-copied the other one, so let's do it again. Okay, so it says that it has found the Docker binaries. I'm just going to accept and continue with the installation. And once done, we need to do one more extra step before we can continue, which is the post install for Linux. If you click here, you can see that there are 2 steps that we have to do. Basically, we need to create a Docker group, and then we need to add the user. For me, the Docker group already exists. I have installed a couple of times already Docker, so this is why I have those set up already pre-configured, but for you probably it's not going to exist. And after you do this, you're going to be able to run Docker commands without sudo. So now if you want to see that our Docker setup is running, we can run this command, which is going to pull a hello world image and run a container with it. I'm gonna omit the sudo just because we added already the user to the Docker group, and as you can see now the image was pulled and the hello world container was started. So this means that we have Docker installed, it's running and is capable of executing containers. Before continuing with installing Minikube, we need to make sure that we have NVIDIA drivers on our system so that we're able to access the NVIDIA GPU. Ubuntu has already provided us with an easy way to install the GPU drivers. I've already installed the GPU drivers, so I just want to show you where you can find some more information if you're running Ubuntu, how you can do this. In this page, you're going to find a couple of ways to install the drivers. You can install either drivers for generic use, such as gaming or desktop, or if you're running an Ubuntu server, you can install the server drivers. I have a generic setup here. As you can see, I have a desktop with Ubuntu. This is why I've picked the generic option, and I've installed it in this way. I had some issues along the way. This is why I'm going to create another tutorial, which will be mainly dedicated to installing the NVIDIA drivers in Ubuntu. So for now, I just want to show you where you can find more information, and I'm going to do a full tutorial on how to tackle the issues when it comes to NVIDIA drivers. Assuming that you've installed already the drivers, let's go back to the Minikube setup and let's continue with the installation. Here you can see those two commands, which are basically commands that download the Minikube executable and then add it to our system. So I'm just gonna navigate to downloads. I'm gonna run the commands here. After being installed, we can run Minikube and we can see that we have the executable already running. So this gives us the chance now to create clusters and to configure those clusters with GPUs, external access, and anything else possible that Minikube provides us. So now we want to start our clusters, but we don't want to start it normally. We want to start it with GPUs exposed. This is why I'm gonna search for GPU in the documentation, and we have this beautiful page here which describes a couple of ways to expose GPUs depending on the driver that you're using for Minikube. We have the Docker driver. This is why for us this is the page that's important, and we're just going to follow through the information here and do the steps necessary to install and enable GPUs. The first step is to check if this configuration here is set to 0. This is a security setting which has to be disabled. So if you check it out, for me it's already set to 0, so there is no step necessary needed. So for me it's already set to 0. This is why it's not needed for me to configure anything else. If you have a value different than 0, you can use this command here to set it to 0. As a next step, we see that we need the NVIDIA container toolkit. So let's just click here. I'm going to open it in a new tab, and this is the NVIDIA documentation where it is described how you can install the toolkit. As a prerequisite, you can see that we need the NVIDIA drivers. This is why I showed you prior to this step where you can find them. So assuming that you've already done this step of installing the drivers, we can continue with the installation of the container toolkit. Let's just do the same. Let's copy the commands. The first one is going to add the necessary repositories. I guess I already have such a file, so I'm going to omit adding the repository. I'm just going to do an apt update. So for you, it's going to be a new repository, most likely, and afterwards you need to update your apt registry so that you can access the driver binaries. And now, as a final step, we just need to run apt install and NVIDIA driver toolkit. For me it was quite fast. I've already done this previously. For you it could take a couple of seconds or minutes depending on your system. And after this is done, you have the container toolkit available on your system, and you can proceed with starting your Minikube cluster. Here we can see that the documentation suggests to delete any older clusters so that the new configuration takes effect. But for me, and probably for you, this is going to be the first cluster. So let's just copy this command and then execute it in the terminal. So Minikube now will download the needed drivers, will set up the cluster, install the pods, which are responsible for the Kubernetes system, and afterwards it's going to provide us with a full-blown Kubernetes setup right on our system with GPU drivers enabled. And as you can see, given the fact that we used the --GPUs all, the Minikube setup has already added the NVIDIA device plugin add-on, which exposes the NVIDIA GPU to Minikube. But there are some extra steps which are needed, which I'm going to show you in the same tutorial now, so that you're able to split your GPUs in multiple, let's say, virtual GPUs, and then run workloads in a parallel manner. So now your Kubernetes is running. You have a Minikube cluster on your machine, but you need to somehow access this cluster. This is usually done through a CLI called kubectl, and if you don't have it installed on your computer, I'm going to show you how to also install it. So let's check out kubectl install, and this is the official Kubernetes documentation. And as you can see, the Kubernetes command line tool kubectl allows you to run commands against Kubernetes clusters. Let's check out how we can install it. For me, it's the Linux version. As you can see, you just need to copy this command and it's gonna install the latest release. So now we downloaded it, but we still need to install it. There are a couple of more steps. Let's validate the binary. This is an optional step, but it's always good to do it for security measures. As we can see, the checksum is matching the expected one, and we can proceed with the installation process. So as a next step, just run sudo install and the rest of the configuration for kubectl. And after that's done, you should be able to run kubectl commands. So let's run the version command, and as we can see, we have a client version for v1.32 and customized version v550. So if we say kubectl get pods, we should have no pods, but if you check all of the namespaces, we're going to see the default Kubernetes pods running. Now that we have configured our Minikube cluster with exposed GPUs and also configured the NVIDIA toolkit for containers, let's give a try of the setup that we created, and let's run a small dummy GPU enabled workload just to see that our system can access the GPU. So for this, I'm going to create a YAML file called GPU expose.yaml. I'm gonna copy and paste a pre-configured YAML, which I'm gonna explain to you what it's doing. So we can see we are starting a pod in the default namespace. It's called GPU test pod. It's running a container called CUDA container, and it's going to start a CUDA base image with the NVIDIA SMI command. It's using one NVIDIA GPU, and this is already available thanks to the NVIDIA device plugin that the Minikube already installed. And now, before installing it, I'm just going to show you how our node looks, what are the resources of our node, and you're going to see that we have a single GPU already exposed and available as a Kubernetes resource for usage. So for this, we're going to run kubectl get node. We're going to see that we have the Minikube node, and then we're going to describe it. Kubectl describe node. It's just a single node. This is why we can just concentrate on the capacity. And here you can see, besides the exposed CPU cores, beside the exposed memory, we have also one NVIDIA GPU resource that's available for access by the containers. This being said, now that we have validated that we have GPU resources, we can run the container and we can see what the output of the container is going to be like. So let's just apply kubectl apply f dash. So let's just apply the created YAML and see what the container does. So we can see that the pod was created. We also see an error image pool and the pod was not started. This means that we have some kind of an issue with the pod, so let's just investigate. I'm gonna copy the name and I'm gonna describe this pod. So let's just run kubectl describe pod and then this name. So we can see in the events we have a backoff pulling image NVIDIA CUDA 11.8 base. This means that there is an issue with the image. So let's just copy this image and check it out in the Docker registry and find out a suitable version which will work for us. If we check the tags, we're gonna see the latest versions. Let's also check out which is our CUDA version. We are running 12.4, so let's search for 12.4. I don't see any such version because it's not probably on this page. Let's search it here, and we can see we have 12.4.1, and those are the development images. We just need this Ubuntu image, and I'm running Ubuntu 22.04. So let's just take this image. Let's update our GPU expose pod. Let's paste the, oops, I did a mistake. Let's redo this. Let's update the version, providing the one that's already existing. I'm gonna save the YAML file, and then I want to delete the pod. So I just want to say kubectl delete pod GPU test, so that we can apply the YAML file again, and then we run kubectl apply -f GPU expose, and if we check out the pods, now we see container creating, which should pull the image and then should execute the NVIDIA SMI command. Okay, so our pod was able to run. We can see that it's now in a crash loop backoff status because it ran a single command, and it was done executing, but it cannot continue. So if we check the, if we describe the pod, we're gonna see that the container was pulled successfully, and then it entered this backoff restarting status. This is because we did not tell to Kubernetes that we want the container to execute only a single time. So if we check out the logs, we're gonna see the NVIDIA SMI output here, and we can validate in this way that our setup has worked. We have all of the needed prerequisites to continue with the installation of the GPU operator, and here I've opened the GPU operator official documentation provided by NVIDIA. Just a bit more context to the operator. That's a operator for Kubernetes, which is responsible for installing the GPU drivers, adding some daemon sets for management of the GPU, and also responsible for the virtualization of the GPU in Kubernetes. It's made more precisely for cloud environments. And now that we're running on Minikube, we did some extra steps prior to installing it, but in the cloud environment, it's going to be a lot easier to get NVIDIA GPUs running, given the fact that you only need a GPU-enabled instance and the GPU operator to start working with NVIDIA GPU-enabled Kubernetes workloads. Now let's follow the steps. There are a couple of prerequisites. We need to install Helm. We need to do some configurations to the security settings of Kubernetes. So just execute those commands. I have Helm installed already, so this is why I'm just going to execute the rest of them. And afterwards, we can start with the actual configuration of the GPU operator. As you can see, I got an error. It's saying that the GPU operator namespace already exists. This is because I've already created such a namespace, so it's existing. We just have to add the GPU operator to the cluster, and then the rest will be taken care of. Let's add the repository for the GPU operator. We see that it was successful. It's available in Helm, and now we can install the release of the GPU operator. So let's run the next command. Now we got it. And if we check out the pods, we're going to see that we have a couple more pods added, which are the ones of the GPU operator. We see we have the node feature discovery, we have container toolkit daemon set, we have the DCGM, the device plugin, the driver daemon set, and some more. You can go to the page that I'm gonna probably add somewhere here, which is my blog. And in this blog page, we're gonna find more information what those containers are actually doing. Now we just need to wait for them. After this is done, we can configure the time slicing approach, which is going to allow us to manage our GPU in a virtual manner. So now that we are waiting for the GPU operator to get installed, let's discuss the time slicing approach, which is an approach that works on, I would say, any possible GPU. You don't need any specific configurations or specialized hardware. You can run it on any possible GPU. I have an RTX 3060 at home, and I can still virtualize it and use it for running multiple pods that are doing basically oversubscription to the GPU. If we check out the docs, we're going to see that the GPU operator enables oversubscription of GPUs through a set of extended options. The GPU time slicing enables workloads that are scheduled on oversubscribed GPUs to interleave with one other. Here, it's very important to be careful to not cause out-of-memory errors. This is done by the developer, in my opinion. So whenever you're developing GPU-enabled workloads and you're using time slicing, you should be very familiar with how much resources your pods are using, so that you can develop budget for the pods and make sure that even if you're starting multiple pods, they're not exceeding the memory that the GPU has. Let's see how the installation process is going. Okay, we see that everything is done. Now if we describe our node, we're going to still see that we are going to have a single GPU as a hardware resource, and we want to make it so that we have multiple replicas or multiple virtual GPUs that are available for our pods. So here under capacity, we see our node has just a single NVIDIA GPU for now. What we're going to do is we're going to create this time slicing YAML file. And we're going to copy this configuration map. Let's say we add 10 GPUs to our system and we save the YAML file. We then need to apply the YAML file to our NVIDIA GPU operator namespace. So now it's added. We just need to patch the cluster policies to make sure that they're using this time slicing config map. So now we need to wait for our GPU feature discovery and NVIDIA device plugin pods to restart, which will reflect the changes that we did, and our node will have more virtual GPUs available. Let's check out our logs. And I think I can see the pods being restarted. Let's make it full screen. Yep, it says that before 30 seconds they were restarted. So this means that we have the changes reflected. If we check out the node again, let's describe the node, and under capacity we're gonna have, as you can see, 10 virtual GPUs. This means that now we can schedule more pods on our single GPU, and it's still going to be capable of executing them. So lastly, let's give it a try. Let's see how this whole thing works. We're going to use this YAML file here, which is called time slicing verification. It deploys a couple of pods, each of them requests a single GPU, and then run a simple vector add operation. So let's copy it and let's apply it. Let's create the file. Let's call it just test YAML instead of this long name, and copy paste it. We see there are going to be 5 replicas. Each of them is using a single GPU. So if we say kubectl apply -f test YAML, we see that it was created. So if I run kubectl get pods now, we're going to see that those 5 pods have started, and those are the pods from the test deployment that we have created prior to executing the command. And just to show you what happens once you try to use more GPU resources than what is available or what you have configured on your system, I'm gonna edit the test file. I'm gonna request 11 replicas, each of them using a single virtual GPU. And I'm gonna apply the test file. So now if we check the pods, we're gonna see that all of them are running besides this one. So given that we have 10 virtual GPUs on our system, it could handle 10 pods which request a single GPU. And the 11th pod will simply wait until another one is deleted so that it can get handle of the GPU resource and execute properly. So this is how the GPU setup is working. I'm gonna do more tutorials in the future showing you how you can develop workloads that allow you to utilize your GPU fully, and how you can manage also the situations in which an OOM could happen, and some strategies for managing situations in which this issue still appears.